Welcome everybody, my name is Gael Fraiteur, I'm the founder of PostSharp, the lead developer of PostSharp, the inventor of Metalama, and today I will introduce Metalama, I will give an explanation of what it does, what it is good for, and how it compares to PostSharp, and what is the roadmap. So this webinar is not going to be a tutorial about how to do things step by step, but rather what you can do with Metalama. So first I will repeat what problem Metalama tries to solve, a bit the same as PostSharp, but quite enlarged. Then I will introduce a few concepts of Metalama, and then the main part of this webinar will be a demo. Then there will be a first Q&A, more technically oriented. So if you have any question, please use the Q&A feature of Zoom. My colleague Daniel is online. He will then read out the questions. So this first Q&A should be rather short, maybe 10-15 minutes, but not more, so that like people who are short in time doesn't need to stay so long. Then I'm going to have a few general slides about the roadmap, like comparing Metalama and PostSharp, licensing question. Then we will have another Q&A section. So the problem that Metalama solves is actually a bit the same as PostSharp. It is an evolution of PostSharp. So the two problems we solve is boilerplate and architecture decay. So boilerplate is the repetitive code. This is code that is quite stupid, but not really always. It's very repetitive, but it is necessary for the feature. And the cause of boilerplate is a limitation of the C# language. The C# language doesn't have an abstraction mechanism to encapsulate repetitive code like patterns. The other thing that we are trying to fight is architecture decay. That means architecture decay is the gap that increases, like week after week. You have a growing gap between the ideal software implementation that you imagine during the design and the actual implementation of the architecture in the source code. So architecture decay is a complex problem. There is not a single cause like the lack of a pattern keyword in C#, but one cause is the lack of automation of validation of the source code against the initial architecture. So these are two problems that Metalama tries to solve, and these problems have real cost for you, like waste of time because you need to write boilerplate code, like the code is too complex because of boilerplate code, or because of the irregularities of the code compared to the architecture. There is a lot of defects, bugs in the boilerplate code, or that bugs that come from the excessive complexity. And finally, maintenance is expensive. It's too expensive because of complexity defects, and your code is unreadable. I will not go very far in this description, because I assume that most of you guys have experience or know PostSharp, so the problem is not very different. It's just that the solution that we are bringing with Metalama is much better. So Metalama is a complete rewrite. It is not even PostSharp. It is a rewrite of the same features of PostSharp, but based on Roslyn. It is a completely new architecture. So, and we call that a metaprogramming framework for C# because it goes much further than the initial aspect-oriented programming, which is a concept that was developed already 30 years ago. So Metalama has three pillars. The first one, probably the most important is boilerplate elimination. This is what PostSharp historically started to do, and Metalama still does that, and it even does that better than PostSharp. That means that during compilation, Metalama generates code that does things at runtime but does not appear in your source code. So you don't have to maintain this code, you don't have to write this code. This is the first pillar. The second pillar is coded architecture validation. That means that Metalama gives you tools to validate the source code against any rule that you want or that you are able to code. And so this was present in PostSharp 2, but not very well developed. In Metalama, this is much better. And the third pillar are live templates and code fixes. So that means integration with the refactoring menu in Visual Studio, like the light bulb menu or the refactoring, the screwdriver menu. So this is completely new, and you didn't have that in PostSharp. And at the center of these three pillars, aspects are still the center of everything, the base of everything, because aspects are the things that provide advices, that transform code, that provides validators, and that suggest the code fixes. With Metalama, we are adding another concept similar to aspects. These are fabrics. Instead of explaining that theoretically, I will show you in the demo. So Metalama, as I said, is a complete rewrite based on Roslyn 4, Visual Studio 2022, and .NET 5.6. We started with .NET 5. So this is the stack that you will need on your developer machine. We will not support Visual Studio 2019. We will not support a developer machine without .NET 6. We just drew a line in 2022. We are not going to support all technologies with a completely new product. But for user projects, for the target platforms of your project, then we are much more flexible, because you can actually target any platform that is compatible with .NET Standard 2. With PostSharp, we had quite difficulties with that, because we had to execute the whole assembly within the .NET Framework CLR or the .NET Core CLR, and that was a problem. Now we no longer do that, because we integrate inside the compiler. So we are much more flexible. You can use any version of C#, and you can target. You can use actually any Roslyn-based IDE with approximately the same set of features. So how does it work? We integrate with Roslyn at design time, at compile time. At design time, we integrate with the standard extension points. We do not add our own extension points, because Roslyn is hosted by Visual Studio and you install Visual Studio. But at compile time, we replace the compiler by our own fork, because Roslyn, the non-forked Roslyn is not able to replace code by another code. So you cannot like transform code. You can add new code, but you cannot transform it. So this is our architecture here. So we integrate with analyzers, with suppressors, with code generators, code fixes, and code refactoring. This is all used at design time, but actually at runtime, at compile time. Sorry, we have our fork of Roslyn that includes a new extension point that we call code transformers, and this is how we are able to change the code by the code with the aspects. So this is how we integrate, and that was enough. That these were enough slides. So let's switch to some code and see that in action. Let it write, and I will switch to, we are in Hyper-V here. Yes, this is my machine. Okay, so let's start with the very basic and show the hello world example of any aspect-oriented programming framework. This is logging. So the way that you do logging in Metalama is that you create a method template. This is a method template here. And in Metalama, you have, except the word lama, you have the keyword meta. This is the most important. It's pseudo keyword, but you can consider that as a keyword. So meta. Meta gives you access to the meta model. So anything you see here on the right of the meta keyword here, the whole expression is a build time, a compile time expression, a meta expression. So everything that is grayed out here with a gray background is evaluated at compile time. So we have a method template where the compile time expressions are grayed out, and the rest that has white background are runtime statements and expressions. Here is something very magic. Actually, everything magic here is pink. So meta.proceed calls the method that is being overwritten or templated. So the name proceed is a long tradition. It comes from AspectJ in 1990. So we chose to keep this tradition in AspectJ. It is called join_point.proceed. So we continue with that. So this is an aspect mixing runtime code with compile time code. Now, this class override method aspect is a custom attribute. It derives from the system.class attribute, system.attribute class. So it's a custom attribute. I can add this as a custom attribute, and I can now this is going to log my method. So if I run this, let me click here to run this. You see that it's being logged. So now, if I want to debug the code and see what's really happening, I can choose the Llama debug configuration. So this Llama debug configuration does not exist when you create your solution. You need to create the solution yourself, but you need to map it here to Llama debug project configuration. The project configuration will exist. And what this means here, the Llama debug configuration means that we are going to step into the transform code instead of the source code. So here you see I'm stepping into the transform code. But this may be not what I want. Maybe that I trust this code. I want just to debug the business logic. So I'm switching back to the debug configuration, and now I'm debugging the business code. So we have these two solutions. Very often, instead of debugging a method, it is very useful to go and preview the code, compare the source code with the code that is going to be executed. So here you can see immediately, and you can compare very easily the template, and you see meta.proceed has been replaced, and here these were the expressions, the compile time expressions that were replaced. So that was the first example. We can have another example that is also simple, and it would be a retry aspect. So how do you do a retry? You have a for loop. Within the for loop, you have a try catch, and then you will catch the exception. And when there is less than n attempts, you're going to write a message and wait for some instance and then retry. Here, to make things a bit more complex, we have defined a property for the aspect, and this is a build time property. So this is actually going to be compiled into a constant. So let's see that this is my method. I'm applying retry here, and you can see the template has been applied. Now, what if I want to have more retries? I want 5 attempts. You have 5 attempts. This is simple. We can start making things a bit more difficult. The templates can be actually complex, actually arbitrarily complex. Here, I would like to have still logging. We are still in the hello world scenario, but I would like to have the method parameters inside the logging string. And for this, I would like to have an interpolated string. So instead of creating a string builder, I will create an interpolated string builder, and I'm starting by adding, actually this is not an exception, an expression. I could say that this is a static text. So I'm adding a static text, and then for each parameters, I'm going to add also the text that includes the name, but then unless the parameter is an out parameter, I will add an expression, a runtime expression that includes the parameter value. Otherwise, I'm going to add the out keyword. So this is just to prepare my string builder. And finally, this is the template. This code is no longer in white background. That means that it will be injected into the target method. So here you can see how I can mix runtime code with compile time code, and this all is quite smart. So if I preview the diff here, you will see that I have generated the interpolated string exactly how I would have expected. I can start this, and you can see the result here. So now if you want better formatting and so on, this is just compile time code. You can make things as complex as you want. So these 3 examples demonstrated how you can transform code. With Metalama, you can also introduce members, so add things to your code. And this can be very easy. The easiest way is just to have an aspect that has some member, and then you have the introduce custom attribute on the member. And then you just add the custom attribute on the class, and you see what's going to happen. Now, a side note, look at the partial keyword. If you don't use the partial keyword, actually, Metalama itself doesn't care because it's going to generate the code anyway, but this code is going to be generated at build time and not at design time to make the ID property available at design time. Because of the design of C# and source generators, you need to make the class partial. Because when the class is partial, then Metalama can integrate with source generators and emit another part of the partial class here with the property. You see here that the property is not initialized in the design time file, because most of the time you do not need the implementation of anything at design time. You only need the declaration. So that's about introducing. And now that we know how to introduce new members, we know how to modify existing code, and now we can combine both. So here is an implementation of the notify property change aspect, and to implement notify property change, you need to add an interface, you need to add a property change event, an on-property change property, and then you need to override or to edit every property setter to check for a change and then to call the on-property change method. So this is the pattern. If I had to explain the pattern to a junior developer, this is how I would do that. So it's exactly the way that you do that with an aspect. So the entry point of your aspect is always build aspect. This entry point exists all the time. It's just that for some aspects like this one, like override aspects, we have predefined things so that it's easier to get started. But actually, every aspect has a build aspect method, and this build aspect method adds advices. It adds advices to the aspect. That means it says what the aspect needs to do, and advice is a transformation. So first step, we are going to implement the interface and notify property change into the target type of the aspect. Where do we find the interface members? Well, within the aspect, the interface members must be annotated with the interface member custom attribute. And then the implement interface method actually knows how to map things. It's not the first step. To introduce a method, you know from the previous example that it's enough to have an introduce custom attribute on the method that we want to add. Here, we specify the strategy of what should happen when the method already exists, and we choose ignore. We could have chosen fail, so we would have an error, or we could have an override, or we could have like override with new and not with override. So we have different possibilities. So the next step is to go and override all property setters. So we enumerate all properties in the target type. We select those who are not abstract and that have a writer, and we override the setter with this method. And here is the template for the new setter. So we have the template here. We compare the value with the current value of the property. If it is different, we proceed by calling the intercepted property setter, and then we call the onProperty setter method with the name of the target property. Let's see that in action. I have a vector class with just two properties, x and y, and I'm adding the notify property changed. I can show the diff. You see that the code here is no longer idiomatic. Okay, you would probably write it a bit better, but semantically it would be the same. So instead of having an automatic property, you now get an underlying property or field, and you have this logic. And of course, we add the interface implementation here. So let's see if we are going to have the event is going to be raised. Yes, that's going to be raised. So I've shown how an aspect can provide modifications, transformations into code, transformations of code. Now let's see how an aspect can emit warnings or errors. And to do that, I'm going to go back to my logging example. But I would like to have to make logging a bit different. So instead of logging to the console write line, which is nice but it's difficult to test, I will use a pattern that would that would ideally use dependency injection. But so the pattern is that I will use a logger field that I will assume is a text writer type, but in practice it would be an iLogger type or something for logging. And in my template here, that was from the previous demo, I'm going to use this logger field here instead of console. So here is some magic. Meta does this will be compiled into just this. However, this is of a dynamic type. You can see here in the tooltip here that this is of dynamic type. That means that the C# compiler will accept anything on the right of this on the right side of this dynamic member. So actually, this is going to compile into this .logger.writeLine, and then this is the normal code with a compile time expression. So now, if I have an aspect that requires a field logger, and it requires a field logger that is of type text writer, I would like to emit an error if the target type does not have this field. So to emit an error, the first thing I need to do is to define a static field, and it is important. It needs to be a static field in the aspect class. Otherwise, you cannot emit an error without that step. So you need to define this static field, telling the ID, the severity of the diagnostic, and the error message. The error message can have placeholders here, and we recommend to have strongly typed diagnostics where every placeholder here is an item tuple of the right type. So first step, you define the diagnostic definition. Now you go to the entry point of your aspect, which is build aspect, and you go and you use the code model to find the field that you want. If the field does not exist, or if it is not of the right type, or if the field is static, then you would report the error that you want. And then you say that the aspect should not be applied. So let's see if that works. If I comment this out, to wait a couple of seconds, and you see immediately that the program class has an error, and this is exactly the error that we defined in the aspect. So you could do things like this in PostSharp, but it would not be visible without recompiling everything. So this is a new feature or improvement of Metalama, is that we are able to have a design time experience, because Metalama runs within Visual Studio or your editor. Another thing you can do to validate the code is to define the eligibility, because here you see if I'm using this .logger, well, it will only be possible from static methods. And like here, you see that the add logging action is proposed from the light bulb menu. But I would like the log action not to be proposed when the method is static, because it doesn't make sense. So to define this, we have a concept that we call eligibility. So to define eligibility for your aspect, you need to override the build eligibility method, and then you use the builder to add the requirements. For instance, here we define that the method must not be static. We could also say that it must not be abstract, and so on. These are all predicates that you can add, and actually you can add any custom predicate. The eligibility has two effects. One is that it integrates with the light bulb menu so that you do not get suggestions for aspects that are not eligible. And the second is that if you do that with code anyway, you are going to have an error report, which sometimes doesn't work. In this demo, I will need to compile, since we have a bug at design time for eligibility. But if you compile this, you will see that the build fails because this is here. The build fails because the aspect log cannot be applied to this method because the method must be non-static. So you also get validation for cheap. You don't need to do it manually. So you have two benefits of this. And another feature related to warnings and errors is that you can suppress warnings and other diagnostics. So look here, we have the logger field, but this field is grayed out, and I have an information message here telling that this field can be removed because the value has never been read. But remember that this is a message that comes from the design time part of Visual Studio, not from the compile time part, and the design time part doesn't see the aspect. So actually this message, IDE 0052, is irrelevant because the aspect is there. So what you can do here is to suppress the diagnostic. This is this example. So additionally to adding an error, I will suppress IDE 0052 by editing build aspect. I will add a call to builder.diagnostics.suppress. I say what should be suppressed and on which declaration it should be suppressed. So here you can see that here the field is being used. If I remove the aspect, then it is no longer being relevant. And that works nicely at design time. You don't have irrelevant warnings. With PostSharp, it really became a problem because in the last years, the number of relevant warnings, like the Roslyn team and the .NET team has done quite a good job in analyzing code and providing relevant feedback, but it didn't see the aspect. So actually, while using aspects, you didn't have a good design time experience because of that integration or that lack of integration. And now you can suppress warnings that are irrelevant. So that was the first chapter of this demo, and I'm going to move into the second chapter. The first chapter was all about transforming code. My second chapter is about validating code. And here is what I want to do. As an example of validating code, I would like to have a custom attribute, an aspect. That means that the target method, the target class, can be used only in tests. You probably know that you have a nice class that is and you have a nice API, but there are a few methods that should be used only for tests, for unit testing. They are not designed to be used by production code. And normally the way that you enforce that, well, you don't enforce, you actually write a comment, please do not use that, it's only for testing. Another scenario is that you may have methods or constructors that are design time only. So how do we do that? What we want is, we want to have a warning or an error when this method is called outside of a test context. But when it is in a test namespace, we want no warning. How do we do that? Actually, very simply. We create an aspect. This time we create it from the interface because we actually want the aspect to be used from everywhere. And we define a diagnostic definition for the warning that we want to emit, as usually. And then in the build aspect method, we register reference validator for all kinds of references, and this is going to be the method that will validate the code. And it really needs to be a method. It cannot be a delegate, because actually this is going to be serialized for the cross-project scenario. So the validate reference method is also simple. You get a context object, you have the referencing type, and you have the reference declaration. So if the namespace of the referencing type doesn't end with test, we will just report the diagnostic. And this is absolutely all you need to do for that. So you can validate architecture using this, and the basic mechanism to validate is to register reference validators. Now, you can use that in different scenarios too, and for this I will introduce a concept of fabric. So a fabric is very like an aspect, but it doesn't need to be applied on something because it is always being applied by default just because it is there. So a namespace fabric is an aspect that applies to the namespace just by the fact of having a class that inherits namespace fabric inside that namespace. So the main method, the entry point of a fabric, is the amend method. So here we have amend namespace, and here what I would like to do is to say that this namespace is internal, and internal means that, I imagine, it's just my own imagination, and it's not something written in stone. This is just the thing that I want to implement now for the sake of the example. So I would like the internal keyword in this namespace to mean that the declaration can be used only in the current namespace, including the children. So how to implement that constraint? So I have a fabric, I have the entry point of the fabric, and here I call with target members, and here I'm choosing all types, but all internal types within that namespace, and I register the reference validator. You already know the reference validator from the previous example. This is the validating method. I take the reference namespace, the referencing namespace, if the namespace are different, and the referencing namespace is not a descendant, a child of the reference namespace, then I'm going to report the error message. So this is actually all I need to do, because now you can see that when here is it. I have an internal class. When I try to access the internal class from the same namespace, it's fine, there is no warning. However, if I try to access the internal class from outside of this internal namespace, I have an error. So that said, it's possible to ship constraints as NuGet packages, so that instead of having these lines of code here, you would just have amender.internal namespace. So you can build extension methods, of course, and to follow the pattern of application builder from ASP.NET Core, you can do this too. So let's move forward with the fabrics, because actually there are four kinds of fabric. I have shown the namespace fabric. There are the type fabrics. Type fabrics can modify the type. So type fabrics are nested types. They modify the types in which they are contained. They can add aspects. They can add advices. They can validate things. So A type fabric is an aspect added to the same type. Project fabrics are fabrics that are defined for the whole project, and then there are transitive project fabrics. Transitive project fabrics are applied to all projects that reference that initial project. So they are transitive, like by reference. So that means that you can actually transform assemblies that import you. So I don't have examples for that. I have an example for a project fabric here because the use case here is different. I don't want to validate. I want to log everything. How do I log everything? I create a class that I name however I want, but it needs to, it must derive from project fabric. We implement a main project, and then we select the things that we want to log. Here, I want to log all methods of all types. It's not going to select the nested types, pay attention. And then I'm adding this aspect log attribute. So just by having this class here, there is no other custom attribute. Actually, log attribute even can be an aspect that is not an attribute class. I'm adding. So by having the fabric, it doesn't matter if I have 2 classes or 1,000 classes, of course, I have logging everywhere. And all the logic is here. So fabrics replace multicasting in PostSharp, and it also replaces PostSharp.config. I will show an example here where a fabric can be used to configure an aspect. The logic here is that I would like to do logging in some color, and I would like the color to be configurable. So I'm defining a log options object. It must be a project extension, and it just exposes the color. So then the logging attribute consumes the color here, consumes the setting. I forgot to show you the project. This is a simple method. Also, in the philosophy of the ESP.NET Core builder design, the pattern that we define extensions like this. So once this extension is defined, you can read the color from your aspect, and you can set the color from your fabric. So fabrics, they are going to be added to your project automatically from parent directories. So you can have fabrics that configure your whole solution. This is possible to do. You don't need to manually import all the fabrics. You can have many fabrics, and they are going to be ordered by depth of. So, I mean, the closest to the root of your repo is going to be executed first. So fabrics cover the use case in PostSharp of attribute multicasting. So adding aspects to many declarations in just a few lines. It covers configuration, and you can also register validators using fabrics. That was my 3rd chapter about fabrics. And now I would like to go to my last chapter, which is IDE interaction, how to generate code not at build time, but how to generate source code. I will give a first example with toString. I need to reset my example first. Yeah, that was okay. I will keep it like this. So I would like to create a good implementation of toString, but I would like the user to be able to see the code in source code. So I don't want an aspect. I actually want to generate the code. I will actually revert. Yes, I will revert to a more complex implementation. So here I have a pretty good implementation of toString that creates an interpolated string builder, appends a type name, and then goes after all non-static fields and properties and just write them in the string builder. So, and yeah, the important thing is that I mark the aspect class with the live template custom attribute. And what this does, additionally to offering to add the aspect as a custom attribute, it also offers to add the aspect as a live template. That means that the aspect would be applied directly to source code. So there is a bit of a terminology issue because an aspect that modifies your source code really is not really an aspect according to the classic interpretation of aspect-oriented programming. I don't know. It still uses all of the aspect-oriented technology. It's just that we apply that to the source code. I don't have any decision on this question yet. But that means for you, it means that you can create pretty complex code refactorings for your users based on the same technologies that you use to create aspects. So instead of providing implementation guidelines of how to implement toString, you can actually provide a real implementation that will generate the code that then the users, or your developers in your team, they can use that live template and then edit the code. I will go a step further. Just restoring that. I will go a step further in this demo. It will be actually the last demo. To show this time it is not a live template, but you will see. So I want to have an aspect toString. So, and toString is going to generate the classic things. It goes after all properties and it prints them. But I want to give the user of the aspect a bit more flexibility because I don't want them actually to always do, generate the code and then go edit the code and remove what they don't want because, well, it is not optimal. I want to give them the opportunity, the possibility to tag a property with a custom attribute, not string. That means not toString means it should not go into the toString implementation. So how I can do that here inside my introduce toString implementation, I can add a condition. I'm only going to take fields that do not have any custom attribute of type not toString attribute. So I can do that. This is simple, but I can go further. I can help the users of my aspect a little more, and I can actually suggest a code fix, so I can add a suggestion to the refactoring menu. So in the build aspect method, I'm going to iterate all my fields that are not static, and those who are not yet enhanced with this custom attribute, I'm going to suggest a code fix, and the code fix will be to add a custom attribute to the field, and this custom attribute will be of type not toString, and this is going to be the text of the code action, and this is the target of the code action. So let's see that in action. Going here, I want to exclude this, so I'm going to the refactoring menu, and I have exclude from toString. Okay. And now, the next step, I still want users to be able to override that. Like, of course, I could tell, well, you go here to the div view, you you copy paste. I could do that, yeah. But I have a better way. Here I implemented the action, which I see is broken. Let me retry that. No, not breaks on time, and I never know why. It seems to be Visual Studio. Yeah. Okay, I don't know. I don't know what's happening. Okay, something is broken, and I will show you what I wanted to do. So I wanted to propose to suggest a new code fix would be to switch the aspect to manual implementation. So this is a bit more difficult. It is not just adding a custom attribute, because actually there are 3 steps, and these are the 3 steps. The first step is that I'm going to apply the aspect manually to the source code. Then I'm going to remove the toString attribute, and then I'm going to remove the not toString attribute. And doing that, I don't know what is broken here. Oh yes, I know. I need to go. I need to go here. No, it doesn't do it. Okay, but so you would have the action proposed here, and if you do that, it's going to remove the custom attribute here, and it's going to implement the toString. And that's all I wanted to show. I'm going to switch back to PowerPoint just to summarize what we've seen here. So I have shown boilerplate elimination. This was the first chapter of the demo, to show the different things you can do to generate code, and that code most of the time would be generated behind the scene during compilation. I have shown how you can validate architecture with code, especially references. Of course, you can also validate declarations, but here, most important is declaration. And I have shown, or try to show, how you can create your own code fixes and live templates. So how did we do? So Metalama will save your time, because you don't need to write the boilerplate code, or it is generated at compile time. So you don't need to write it, or it can be generated at design time inside the IDE. So this is the first and easiest way that you are saving time. Is actually not the biggest one, but it's just the easiest to explain. So that's important. So we are reducing complexity, because the boilerplate code is no longer in the source code. So the source code is simpler. This is one thing. But also, just by the fact that you are validating the code, it means that inside your source code, you have patterns. Patterns mean that you have a lot of repetition. You have a few rules and a few exceptions. So the informational richness of your software is lower, so reduce complexity, both thanks to boilerplate reduction and to validation, but also thanks to code fixes suggestions, because when you provide your team with code fixes suggestions and code refactorings, you are creating alignment in your team, because you are suggesting people how to do that the way that we want things to be done. So not everybody can use these suggestions, instead of having to reinvent everything and come to very heteroclite solution. So as a result of having fewer lines of code and lower complexity, you have fewer defects, and eventually your software is easier to maintain. That means that instead of having a lifetime without big rewrite of say 5 years, it could be of 8 years, which could be a huge difference. So I'm just throwing numbers just as an illustration. But some software applications have a lifetime of 20 years. So improving maintainability is important. And this is time for the first session of questions after already almost 1 hour. Daniel, do we have questions?
Hello, everyone. Currently, we don't.
Don't have questions? Okay, so I'm going to continue. Still time to ask questions. There is no more technical content. So if you have any question with the previous things, it's a good time to do it now. Okay, so Metalama with versus PostSharp. So PostSharp was designed in 2005. Metalama was designed between 2020 and 2022. PostSharp was between 2005 and 2010. So Metalama is much more modern. Metalama is platform independent because it doesn't run the whole assembly that is being transformed, but only the gray code, only the compile time code is actually executed within the compiler. So it is designed from the beginning as platform independent. Metalama will be faster than PostSharp, both at compile time and runtime. Compile time because it doesn't need to disassemble the code, like read the binary, change the binary, everything. But it already uses the object model of Roslyn. It doesn't need a complete full cycle. And it will be faster at runtime because actually the code that you inject is exactly the thing that is going to be executed. In PostSharp, if you use the simple APIs that we provided, it created a lot of over allocation because of the context objects. The context objects were passed on the heap. So this created a lot of allocation. With Metalama, you generate C#. You've seen also with Metalama a much better design time experience. I've not shown that, but actually with Metalama, you have much less of a vendor lock-in. There was never an intentional vendor lock-in with PostSharp, but if you had to remove PostSharp, you had to write the whole source code by yourself manually. With Metalama, you have an exit door because you can always generate the code back. The problem is that this code is not idiomatic C#, but this is C#, and you can use other refactoring tools to reformat the code to something that is more idiomatic. And we are going to make it to try harder to make the code nicer. So other benefits. So we have fabrics that cover multicasting, project.config, very good replacement, live templates that improve the design time experience, code actions. Architecture validation is really improved. Documentation is a completely new generation. We have unit tested documentation. We have an online sandbox where you can open documentation examples online, try them without installing anything on your computer. We have a linkpad driver that I did not show today. We have a testing framework, so you can actually test aspects and test that they generate the code that you expect to be generated. We have released the exact same framework, testing framework that we are using internally. So our objective with Metalama is to be compatible with PostSharp, but actually our objective is that your business code will be compatible and not the aspect code. So typically, any customer of PostSharp has, like, typically is 5, 10, 20 is really generous in terms of number of aspects. So say 10 10 aspect classes. So these aspect classes will need to be rewritten. There will be feature parity, but there will not be any kind of compatibility. But what we intend is that the rest of the business code will not require any change or not any significant change. So changes would be required in potentially 1% or I think less, even a tenth of a percent of classes. That would be the objective, because you would be able to generate to create aspects that do exactly the same thing as in PostSharp. So we could not implement backward compatibility completely with PostSharp because the architecture is completely different. There is a gap of 15 years between both designs, and we wanted to start from a green field because 15 years is really a lot of backward compatibility. So we took that choice. That said, we want to provide migration assistance to customers. That means that if you want to start using Metalama, if you want to be one of the first early adopters, then we not only want your feedback, but we are going to help you. We are going to connect to your developers, do peer programming, and if you allow us, and if it is technologically feasible, we could also clone your repo on computers and port the aspects and like push it back. I do not see on our side a limit in how we could have this cooperation. So this is up to you. It will be so the criteria is, well, first asked, first served, but also in case of that we have many customers in the same phase, we are also going to look at, well, are we prepared? That will be the first thing. Do we support all the features that we need? Is your project urgent or not? We cannot really afford having urgent project at that time. This kind of criteria, but we are a small team, very flexible, so it's all about discussions. Licensing. So Metalama is free while in preview. All PostSharp customers will have Metalama at no cost. Your PostSharp license key works with Metalama. There will be free licenses for open source projects, influencers, students, teaching rooms, so very broad free offering. Additionally to the business licenses that we had with PostSharp, we are introducing a named license only for individuals, and they are given a 60% discount, which means 40% of the price of the business license of PostSharp. So I repeat, this will be only for individuals. And we have a free edition of PostSharp Metalama Essentials that frankly covers everything that any free competition can do. So anything you can do with any open source competition of PostSharp, well, you can do that with Metalama. It is a complete replacement for anything free. Yeah, and there are other features I did not show, but you can actually create low-level aspects. You can access the low-level Roslyn API. It's more difficult. It's not for a 90-minute demo, but this is possible. The roadmap. Well, our first milestone, our first release, Metalama 1.0. The objective is to reach feature parity with PostSharp framework. However, there will be a few exceptions. So features that will not be in Metalama 1.0. So we will not support cold site aspects. We will not support advising the await keyword, because in PostSharp we had the state machine advising that you could have on resume, on suspend. So we will not have that. We will not have PostSharp tool for Visual Studio, and we will not have the pattern libraries. So we are actually reaching for most of the features of PostSharp framework. Even with this feature set, it's still an amazing product. Compared to our objectives for Metalama 1.0, we are almost there, but not completely yet. So what is still missing is overriding events, constructors, introducing operators. I think is something we should do in 1.0 because it's simple and useful for some patterns. We still have some gaps in unit test coverage and lack of real-world testing, which is why we are offering KVR support for free. And then after Metalama 1.0 has been released, which I guess we should get within a couple of months, so we are going to move forward to port the PostSharp pattern libraries to Metalama, because PostSharp pattern libraries are implemented based on the PostSharp framework. We are going to rewrite only the aspects to use Metalama framework, and for this we will need features like advising of await call site aspects. This is going to be in the next versions. I don't want to say in exactly the next version singular, but in the next versions plural. Yes. So to get started with Metalama, well, typically the first thing to do is to add the package. So Metalama is a set of NuGet packages, and you would add this package to your project. If you are writing aspects, then it is very useful to install Metalama tools for Visual Studio. It is not required, but this is the add-in that provides syntax highlighting and this info bar that tells you that you are done with editing the changes, and the diff, the diff source code and transform code. This is provided by this. So this is highly recommended. It's possible to do that without. To learn more about Metalama, you can go to the documentation. Still, it is already in pretty good shape. We have an online sandbox, try.metalama.net, and we have the samples. Actually, the samples that you get on try.metalama.net are those that are in the Metalama samples GitHub project. The source code of today's demos are in the Metalama demo project. However, if you are looking at it right now, it will not work because I was not able to publish the binaries today because of the Azure DevOps shortage. So this demo was done with an internal build. And this is all I have. Do we have questions? I do not see anything in the Q&A. If anybody wants to ask a question, please, you can unmute yourself and just ask. I can show more code. Entirely up to you. Just going to wait 5 seconds and. Okay, no question. Good, so that was all I have today. Thank you for your attention. And yes, I wanted to say one more thing. The best thing to get in touch with us is to open Slack, to go to our Metalama support page. There is a Slack button, and I will answer on Slack. Thank you very much, and goodbye. Have a nice rest of the day.